In this video, we are going to see how we can prove the triangles are congruent. Before that, let's recall the reasons that you can prove the triangles are congruent. They are SSS, SAS, AAS, ASA, and also RHS. Each letter stands for some pair of equal sides or equal angles. For example, S stands for sides, which you'll find two sides are equal in a triangle. A stands for angles, that means there are two equal angles. R stands for right angle, that means it's talking about 90 degrees. And at last, it's talking about H, which is called hypotenuse. It is a very special side in a right angle triangle, which is the longest one. That means the one now I highlight in blue for you. It is called hypotenuse in a right angle triangle. Besides, you also need to note the difference between AAS and ASA because the position of S is different among each other. So we were talking about the difference between them later in this video. To start with, let's look at number 2 as follows. In order to prove the triangles are congruent, normally I will start with some given information first. What does that mean? For example, now you have DAC is BAC, so it is a given information that the two angles are equal to each other. So do write it down immediately so that you can start with the question with a S. This is a A, so which is a given angle, so you have an A already. So as a result, you may think of, the question may be about SAS, AAS, or ASA because you have an angle already. Next, we seek for some other angles. Now the red one, DCE and BCE, they are equal to each other. You find that they are not very good because it's not inside the triangle. So I repeat, the question is talking about triangle ABC and ADC are congruent. But now the red angles do not belong to the triangle. So that's why we need some other tricks to apply it, that we'll talking about it later. Besides given angle, which is the first A we have written, the other way we can start the question will be we seek for some common side. For example, the blue one, now in the picture. And you will see AC and AC are equal to each other because it is a common side in the triangle. So it is also a very good start for you to work on because you have an S here already. Now we have S, we have A, so that's why we are now seeking for the third equal sides or equal angles in order to say that the triangles are congruent. Now we go back to the red one. The red one, we just mentioned that because it's outside the triangle, we can't use it. But what if we look at angle D and angle B? If you read it carefully, you will see that angle D together with angle A, so it's equal to the red one, which is the exterior angle of triangle. So I repeat again, angle D will be equal to angle DCE minus angle DAC because of exterior angle of triangle. Besides, you also see that the angle at B, we call angle B here, so which is equal to, so let's highlight the lengths as follow. It is equal to angle BCE minus angle, this is BAC, also by exterior angle of triangle. Now please pay attention. You will see that DAC and BAC are the same. That means the angles at the back, they are the same. Besides the red one, they are the same as well. I write here, DCE and BCE, so they are equal to each other because of given information. So I underlined in red as follow. Now can you see that, well, you've got these two are the same, which I underlined in red. These two are the same, which I underlined in yellow. So as a result, can we conclude that angle D is equal to angle B? Yes, because they are in the same expression, carrying the same values. So as a result, now we've got the last A in the question, and that's why we almost finished the question. But now we have to look at the question, is it about ASA or AAS? Now let's use a red highlighter and look at the picture. We have angle D here, we have angle called DAC here, which we have proved that they're equal to each other. Next, we have the common side AC. Can you see that now the situation would be a A here, and at last there's a S here. The S is outside the 2A. So that's why the reason we will call this is a reason called AAS. The triangles are congruent to each other. And finally, you write down the statement called triangle ABC is congruent to triangle ADC in the question. Okay, so next we look at another question. So once again, we seek for some given information first, including BC is BQ, BC is BQ, which is given, green color. Perpendicular means that there are two 90-degree over there. Okay, so at last we are looking at triangle APC and triangle DQB. So for convenience, how about we can highlight it as follow. So this is triangle PAC, and this is triangle BDQ. So afterward, now you will see that to start with, so we can write down the given information very quickly, including, first of all, we have PC is BQ, which is given information. Next, we have angle P equal to angle Q, which is also a given information. And now we need one more pair of equal size or equal angles to complete the question. So that's why I start looking at the red one, because AP parallel to QD is the information we haven't used yet. But please do note that it doesn't mean that AP is QD. This is a wrong concept, because parallel is talking about parallel, not talking about the length. But parallel itself gives us a very important information, because can you see that PA and QD, they're connected by AD. So as a result, you can see a big EZ there, which means angle A and angle D, they are equal to each other. Because of alternate angles, PA is parallel to QD. With this, then we now have totally three equal relationships. The first one is a S, followed by A, and also a A. Now we have to determine, should it be AAS or ASA in the question. So that's we need to look at the positions carefully. So once again, we use the red highlighter. We have a A here, we have angle P here, and the side is outside. To write very precisely, you will see that there's an A here, angle P, there's another A, and PC, which is a S outside. Once again, the S is outside the two A's, not between them. So as a result, the reason we will call AAS once again. And finally, you fill in the blanks. We have triangle APC congruent to triangle DQB. It should be DQB. Finally, this is the answer for part A. So the use of SAA here will be helping you to look at whether you have already completed the three pairs of equal size, equal angles in proving the congruent triangles. So in your work, it's better for you to cross it out, particularly in your exam. Next, we come to part B, asking you whether BQ is parallel to BC. So for my convenience, I highlight it by yellow. Because of parallel, you will see that these two lines, they are connected by BC. So as a result, I'm asking myself, is it possible for me to look at these two yellow angles are the same? If so, then you can say the lines are parallel. With the help of part B, it should be part A, because the triangles are congruent to each other, it means that you can see ACP. Okay, I'll write the arrows in this way. Angle ACP will be equal to DB and then Q. So equal to angle DBQ. So you follow the letters of the congruent triangles to find some new relationships or new results over there. Because once we prove that the triangles are congruent, that means everything are the same. Sides are the same, angles are the same, say area are the same, etc. With this, then we have a reason called corresponding angles because of the triangles are congruent to each other. So as a result, then we can say, so you do remember at first we want to say the two yellow angles are the same, so that the lines BQ and PC, they're parallel to each other. And the reason would be called alternate angles equal. Not very hard, right? Next, so let's take a look on a question which is talking about ASA that we haven't come across yet. And to start with the question, we should look at some given information. First of all, you have AD perpendicular BC, but usually the picture will only show you one 90 degree, but actually there are two. So both of them are 90, which you can use the reason called given. Next, we have BE is CE, so a very good one. Lastly, we have angle ABE is angle ACE. Now you have to check whether these two informations or these three information belong to this triangle, ABE and triangle ACE. For the red one is yes. So that's why we can firstly write down BE is CE, which is a given information. Similarly, the green one is also yes, it belongs to the triangle. So that's why we have angle ABE equal to angle ACE, which is also a given information. We have now a S, we have now a A. So that's why we need one more. Unluckily, you will see that these two 90 degree, which is outside the triangle. So that's why we need to seek for a way to move it into the triangle so that to complete the proof. But luckily, you will see that the blue angle and the purple one, so I'm at B and C, it seems to be they are irrelevant to each other. So now the question here will be a little bit tricky. Can you see that BECE implies that the triangle is isosceles? If yes, have you think of something new to you about this picture? Very good. You will see that because of isosceles triangle, we can think of angle EBD is equal to angle ECD. Because of base angles, isosceles triangle. So what's the use of them? Now can you read the red yellow angle and the blue angle and seek for something new to you? If yes, you have a very good observation. The outcome will be the red and the blue one will go to an angle at E by exterior angle of triangle. Say for example BEA, now I've drawn to you. Next, similarly on the right hand side, so you can see the angle called AEC over there. So each of them we need to write some details. For example, like we have to say BEA, the one on the left hand side, equal to angle EBD plus 90 degree because of exterior angle of triangle. Similarly, the one on the right hand side called angle CEA, which is equal to angle ECD plus 90 degree, again by exterior angle of triangle. The most important thing will be, so these two angles EBD and ECD, they are already found to be the same in the previous line. So as a result, we've got the last A called BEA and CEA are equal to each other. That's the last reason we have found, which is belongs to A. Finally, we take a look on whether it's AAS or ASA here, though I told you the results already. So we should have at first a BE here, which is a S. We have ABE, so here, which is a A. And now we have angle BEA, which is a A here. Can you see that the S is now between both A's? So as a result, the reason now it goes to ASA, which is called, and the statement will be called triangle ABE and triangle ACE is congruent to each other. So hopefully you have a better sense of proving congruent triangles, right? Lastly, we come to take a look on the question 7 as the end of this video. Okay, so this time you are asked to prove that the triangles ABE. Okay, this time should be a small one, which is on the left side, and now you have DCE as well. So because there's a big cross, then that means the question should be vertically opposite angles, which is called AEB equal to angle DEC because of vertically opposite angles. how do I discover it? I repeat, because of the big cross. Can you see there's a big cross in the picture? Then there are always vertically opposite angles. After that, we seek for some given things like AE is DE. So is AE DE already given to you? So don't forget to write it. This is a very easy line to write. But now we have a tragedy because we have another information. EBC and ECB are the same. But luckily these two purple angles, they are located outside the triangle. So that's why we need some ways to use them. And once again, it is about a isosceles triangle. Do you remember that when you have two equal angles in a triangle, that means, so I put it in green here, the two lengths here, so they are equal to each other. So going back to this picture, that means BE and EC are equal to each other because of the reason. Do you remember it? Forget, right? So it's very hard. So it's called side opposite equal angles. So now you can see that, well, we have an A here, we have an S here, and we have an S here. So as a result now, we can conclude that the triangles ABE and triangle DCE, they are congruent to each other because of SAS this time. Because there's an S for the AE, red angle is an A, or this one is an A here, and BE is an S. And now you will see that the angle A is between the two S, so that's why it comes up to be the reason SAS. I hope the video helps you a lot on proving congruent triangles. It's time for you to work hard. See you.